Hi, good evening, everyone. How are you doing? Pretty good. Only 2 talks, so I'm going to spend like 40 minutes on this and pretend it was 2 talks. That's fine. Hi, as Brian said, my name is Nash. I'm a developer evangelist at Twilio. Twilio, if you don't know, is a communications platform. That means it's an API that you can use to connect or communicate with your users via voice, video, text messaging, and all sorts of other stuff. We just announced a partnership with WhatsApp to use their API. Much easier than the 3 containers it takes to start up with them. Give it a look. But we're not talking about communications today. I'm talking about passwords. Specifically, I'm going to start with my first password. Any guesses as to what I might have chosen as my first password? I'll give you a couple of clues. I was like 12 at the time. Password? It's actually worse than that, would you imagine? Genuinely, the first password I chose was Nash. And I know you're thinking, that's very short, but it was on a Mac system. It was when I was joining F at school. And the worst thing about this, of course, was there was 3 Phils in my class, so nobody actually called me Phil. They all called me Nash, and I was like, clearly creative enough when it came to password time to consider that this would be an excellent one. I followed that up with another 4-character password, Atom. I must have come out of chemistry class just when I'd got hacked by my friends, because when you set your password to your name, and your name only has 4 characters in, it's very easy to spot. And we were pretty young, and the internet wasn't I think I've done that every time I've stood at this podium. Anyway, should be ready for it by now. I got hacked. They guessed my password, or they saw me type it in, and then they sent some hilarious emails from my school email account to other people with school emails, and it wasn't too bad, right? It wasn't my bank account or anything, but I got hacked. So I learned lessons. I learned lessons about passwords. Passwords are terrible. It's not my fault. It was never my fault. The passwords themselves are indeed terrible. And they are, because we're terrible with them. We are terrible with them, so we need guidelines. And people came up with these guidelines a few years ago. About 14 years ago, the most famous set of guidelines were written by a guy named Bill Burr at NIST, the National Institute of Science and Technology in the US. And he did guidelines. These were not the guidelines. These are my favorite ones. Your password must contain 8 letters, a capital, a plot, a protagonist with good character development, a twist, and a happy ending. More like this kind of stuff. You need an uppercase letter, a lowercase letter, numbers, special characters, probably at least 8 characters long, and that would have saved me from using my own name, at least. But these guidelines have caused other problems. Because it takes people from using a password like password to using a password like password. Which fits all those guidelines, right? It's actually an extra character or 2 in there, and that makes it 10 long, with a capital and a number and a special character, exclamation point. But people are really bad at this, because this is kind of the pattern they then go and use. And I have proof of this from the government of West Australia. No, other things. Right, there are other guidelines, like change passwords regularly. That's the one you hate to open your computer up to, and it goes, you need new password. Gosh. All right, so we'll go from password 1 to password 1, 2, 3. You pretty much tell how long somebody's worked at a company if you know the length of password, the password stays active. But yes, the government of Western Australia shows us how these patterns are formed, because there was a security audit of the passwords of WA's government employees earlier this year. 234,000 passwords were assessed safely. They put them on encrypted drives and things like that and threw them away afterwards. Of those 234,000, a quarter of them were deemed to be weak passwords, that kind of very pattern-based, easy-to-guess kind of password. And 1,464 of them were password 123. In fact, I have the top 20 here, which makes hilarious reading. Password 123 is at the top, followed by Project 10, support, password 1. I like number 5, October 2017, because they went, it's time for a new password. And they went, well, looked at their calendar, that'll do. Or, you know, there's Spring 17 in there as well, or Monday 01. And actually, my favorite one on the list is Logitech One. Presumably, they look down at their mouse or something. People are not very creative with passwords, and so they fall into these patterns. You can see most of these are a capital letter, some lowercase letters, and then some numbers at the end. That's what everybody wants to do. It's easy to remember. So I ended up coming up with a really good password. It's not the one I use anymore, although it's probably still drifting around somewhere, so I'm still not going to tell you it. But I can tell you that it was 8 characters long. It was pretty sweet. It had numbers and letters. Just uppercase letters, though. No need for those lowercase ones. No one's getting those. And it was the model number of a piece of hi-fi equipment that I'd bought at the age of 14. I'd got really into looking at pieces of hi-fi, and so the model numbers kind of got lodged in my mind, and I thought, like, well, it's just random letters and numbers. Probably a good password. The fact that it was then genuinely, like, for anybody who walked into my room, just on display, it's not quite a Post-it on a computer screen. And this, I think, is the best example of Post-it on a computer screen with a password on, because it comes from the picture of the guy who sent out the alert to everyone in Hawaii to tell them it was all going down. So, there's security, yeah. So anyway, I got hacked with this password. Mainly because I used it everywhere. I was so proud of this password. I just use it everywhere because I'm like, this is random. No one's ever going to get this. I repeated it. I repeated it for every single account. And it was easy to remember for me because I'd been talking about this hi-fi for ages. But it got broken because of those public breaches. Because everybody else gets hacked. No, nothing I've done has ever got hacked, but somebody else. To be absolutely exact and accurate about this, the breaches were the Adobe one, the Dropbox one, the Bitly one, the Last.fm, LinkedIn, Discuss, and Tumblr. All leaked my password, my very secure, very safe password all over the place. The bastards. I'm telling you this because I've now changed that password. But I'm telling you this because you should also check if this has happened to you. Go to haveibeenponed.com, put in your email address, and see if anybody already knows your password. They probably do. Have I Been Poned is, of course, a collection of the leaks and breaches that have been publicly kind of leaked out onto the internet, and allow us to go check on that. You're right. Why am I telling you this? Right? This is just my password story, and I could do much better than that. And now I use a password manager, and I'm. Now we. The dark web. For sale, probably. But what I really want us to do is fix this as developers, right? Because we can pick up and use password managers and things like that. Like I'm sure most of you probably do. Hands up if you don't use a password manager. Hack them. Use password managers is a good thing, but we can't make all our users do that. I'm pretty sure like most of us in this room have built a login system or have an app with a login system and it's somewhere. And so we are responsible for those people's passwords and those people's accounts. So how do we, as developers, fix this? Well, for a start, the guidelines are wrong, right? If we say you have to have at least 8 characters with uppercase, lowercase, number, and a special character, then all of the users are going to eventually slide into that pattern of putting a capital letter at the first letter. We're pretty good at that. We're pattern kind of driven creatures. We're pretty used to putting capital letters at the start and punctuation at the end and numbers after the word that we spelled out. And it just ends up as a pattern. So we need to fix that. And in fact, if you've seen the XKCD cartoon about passwords, then you kind of know all of this, right? Like this Troubadour and 3 here looks like a fancy hard-to-break password, but really it's a real word. It's got some common substitutions, numbers for letters that look the same, and like a special character somewhere in there. And in this cartoon, it talks about entropy, the entropy of this password, which is basically how random it is. This is much less random because we have all those rules that set those characters kind of in place when we fall into that pattern. Now the answer here is to use a passphrase from XKCD. The important thing is it's kind of 4 words which make up a long password at the end of the day. And so comparing, in this cartoon, 28 bits of entropy from the Troubadour N3 thing, which will take according to this, around 3 days at 1,000 guesses a second to correct false battery staple, which has 44 bits of entropy, and will take 550 years at 1,000 guesses a second. So that's the kind of password we want our users to use, because it's going to be hard to guess, hard to get at. So how do we change the guidelines? How do we fix this? Well, the people writing them realized the old ones are wrong, apologized for it in the Washington Post. NIST, and then following that, the ACSC, the Australian Cybersecurity Centre, and the NCSC, that's the UK one, the National Centre for Cybersecurity, National Cybersecurity Centre, I don't know, came up with these guidelines. There's a few more of them, but these are kind of the important ones. The Australian one says at least 13 characters. I think NIST in the US says 14 characters. Just make long passwords. Accept all characters. So you got to be ready for those Unicode passwords. And if you're not trying out passwords with emoji in yet, I recommend you give it a try. And then finally, it says don't allow insecure passwords. So I've broken this one down a bit more because that seems obvious. Insecure passwords include ones that have or are mostly made up of dictionary words. Repeated or sequential characters. These are the kind of things that even though you have a long password will lower that entropy, because if you're allowed to just repeat things, again, people like these patterns, so they will do. Context-specific words, like don't let somebody use their password as their username or the app that they're logging into. And then finally, passwords that have been in a breach. Passwords that are out there on the web for everybody to read. So how do we go about doing this in Ruby? Thought I'd better talk about Ruby at some point during this. Well, I had a look around the kind of major authentication frameworks, just to see what they suggest. This is Devise's approach. Default out the box, you have a password length between 6 and 128 characters. That's cool, but couldn't it be 14? It could. It's an easy change. But that's not all of the answers. AuthLogic kind of gives you in version before 5, it gave you this validation, and it gives you this one as an example since version 5. Again, it's just a minimum length of 8 characters here. And clearance, written by Thoughtbot, has nothing at all for the password validation out the box. And that's fine, they're just saying you do it. So we should. There are things to avoid, though. The device security extension, which sounds like it's really all about security and device, follows all of those old guidelines. It's absolutely about building a regex that will make sure you've got a capital letter and a number and a special symbol. Password strength similarly kind of encodes that kind of idea, although it does come with a very small dictionary of words, so password becomes an invalid password with the password strength library. On the other hand, firstly, just lengthen the password. Like, this is what we do on Twilio.com these days. You get the occasional tweet complaining about how long the password is, and if people complain about how secure your site is, yeah. Then there are 3 libraries that are kind of useful. There's the NOBSPW, the No Bullshit Password Checker. This is based on a Jeff Atwood blog post, actually, on Coding Horror, where he talks about how the password guidelines were bullshit. It's quite good. It has a minimum character length of 10, though. I'd like that to be more. There is ZXCVBN JS. Which is a bad name, because it's the Ruby port of a JavaScript library, not the JavaScript port of a Ruby library in gems. So ZXCVBN was written by Dropbox to make a better password checker for the front end. And this is the Ruby port for the back end. Also comes with a dictionary, can use a dictionary. And then there's Strong Password. I like Strong Password. This one goes really into the entropy side of things and has a fancy algorithm for that. I want to show you them, actually. Hello. That one still works. Yep. Cool. Let's jump into IRB and just see the differences. What did I start with? Strong password. No. Password strength. What you'll find here, and what I've found all day, is that all of these have wildly different APIs, which is really frustrating. So with password strength, you can just test a password. And this one actually requires you to include a username to test it against as well. So you're not allowed to have the username. But obviously, if you put in password, it's like, nah, let's look at the status of that. Invalid. That's invalid because it includes a dictionary word. But if we just put a simple symbol in there, we're good. And if we put a symbol and a number, then we're strong. So believe that if you like. That's why I don't recommend that one. So let's require, instead, the no BS password. And this one has a, and then I think you pass the password as a, yep, that's cool. All right, let's check. So this one we ask if it's strong. No, password is not strong. But let's try again with a special character. That one's not strong, but it's still not strong with just a single number. What it's really waiting for is for you to have 10 characters. That's about as far as it goes. And you can change that minimum character. Actually, it's pretty good for this because you can set the default character up to 14. Let's go 14. But yeah, it still does the same, has the same problems. Let's try a different one. What else do we have? I'm not going to do ZXCVBN because I can't spell it. If we look at strong password, though, strong password I think is the best one. This one has a strength checker module class, and if we look at password and ask is strong, it's not, of course. If we then look at, let's go to, let's make it password one bang. That is strong, it says. But what you can do with this is actually check the its entropy calculation. Let's see what I can do with this. Let's change its API overnight. Entropy calculation. Let's calculate entropy, isn't it? Obviously. So it says the entropy is 18.5, and its minimum entropy is actually 18 before it starts to say it's not a strong password. And you can change that. But what you can do also is tell it to use a dictionary. And this is just going to pick up the default one on my thing, and that's dropping the entropy to 5.5 because it looks like password. And so if I then change this to ask, is it strong, it's going to say nah. Cool. So using a dictionary really ups the power of what is it called? Strong password. And that's really useful. So that's the differences there. Let's go back here and move on. What about the insecure passwords? These are the passwords that we want to find out, the fantastic passwords that I'm going to tell you where they are. Because having mentioned Have I Been Pwned earlier, which is a great way to check if you've been pwned, it is also now a repository of, well, 517 million passwords that have been breached and leaked onto the web. Not 517 million different ones, just 517 million passwords. We can count and see which ones are more popular as well. This is where you find them, because there's an API. Now, you might be worried that, like, if you have an API and you're like, is this password been found? And they're just collecting those passwords on the other side. They could be. They're not. They've actually all been hashed. So all the passwords get hashed, and then you take your password that you want to check against it and get the SHA-1 hash of that password. You take the first 5 characters of that hash and then send that to the API. The prefix there is that 5 characters, the first 5 characters of the hash. Now that's going to return all of the passwords that hashed to those 5 characters at the start, and then the rest of their hashes. And so all you just check is the remainder of the hash, the other 35 characters. If that's in the file that you returned, then the password has been seen in a breach before. And you can even get how many times it's been seen. There's a Poned gem, which I actually wrote. I'm going to show you. So start thinking up some fun passwords. You want to see how many times they've been breached. Because if I require Poned... Well, let's start with an easy one. Count. Let's start with just password. This is good. 3,533,661 of them. 2.3 million password ones. Pardon? What's your password? Now, if you shout your password out, I'll put it in here and... That's a great question. Of course it's been done 2,800 times. And my second attempt wasn't any better. And my actual secure one has been done 5 times, but I'm not typing it out in front of you. Is anybody using Twilio as a password that's been breached? 6 people. And actually, number 1, 1, 2, 3, 4, 5, 6, that's 22,390,000. It's a popular one, that. Holidays? Oh, wait, like the... That's not a holiday, but I actually really liked the ones from the WA government. October 2017, secure! Woo! But spring 2017 now. Sorry. And for those of you who stare down and look at the first piece of tech on your desk, 2,000 times. And just to complete the passwords we've been dealing with, that one's in there, that one's in there. They're all there. It's, I've only come across one, October 2017, that I thought to put through this. Oh no, we didn't see. Don't use correct horse battery staple. Because it's been done twice. But if you rearrange the words, battery staple correct horse, that's fine. Don't know, because, you know. So you can use the Poned gem in your applications, just raw like that as I used it there. And there is, built by somebody else, the devise Poned password for devise if you want to use it in your devise applications. Of course, you must note, in this particular case, you're putting an API request between your users signing up and being happy. But you can, with this device thing, deal with timeouts and just let them through if the API does fall over. However, the API itself is actually all cached like heavily in Cloudflare, so it's super quick. And that is where you find all those passwords. That is the ones you do find. So passwords are terrible, particularly my ones that I've come up with over my time. But the password guidelines are worse. They're forcing us into worse habits. I mean, not us, but your regular users. So make passwords longer, 14 at least. Just make passwords longer until users are used to 14-character passwords, or they're like, well, I better use a password manager now. Check against breaches and dictionaries. So most of the gems I recommended there have a dictionary or can use a dictionary with them, and we'll check against that. And then check against the Poned Passwords API. You can, if you don't want to use the API, you can actually download all 517 million passwords yourself and host it yourself. GitHub actually do that now. They recently implemented and released that. And what's quite good about that is if you're doing it as a kind of after the feature, you can start checking these passwords on login as well and notifying users if their password, which they think secure, has been used 30,000 times. It's a good idea for that security. And then finally, implement two-factor authentication. If it's that important to your user and to yourself, get on two-factor authentication. I don't have time to talk about that today, but if you want to ask me about that, Twilio does do some two-factor stuff, so do come and ask me. And that is all I have for you. Those are fantastic passwords, and that's hopefully where you can find them. Thank you very much. I don't know if we have time for questions, or I have some bad password jokes. There's a question over there. Or was that, yes, bad password jokes?
Just curious, does hashing your password multiple times make it more secure?
Does hashing it multiple times, what, before you then use it as a password?
When you store it to a database.
Oh, I'm no cryptographer or hashing expert. However, there are recommended algorithms to use to keep them more secure. Start with bcrypt and go up from there, and make sure you salt those. I don't know.
I think bcrypt does actually do the hashing multiple times.
It does do it. That's true.
Yeah, through the stretching algorithm.
That's right. And if you're using something like devise, you can tell it how many times to do it. And increasing that does make it more secure if somebody gets access to all of those hashed passwords. Don't let them do that, though.
Down the middle here.
How do you deal with sites that have maximum size for passwords?
I leave them. Never return. My bank has a maximum size password of 6.
Yes, Westpac.
The one.
I will say that Ruby
They do-
Australia used to bank with Westpac, and we changed. One of the reasons was that shitty password.
It's a terrible idea.
Not good storing hundreds of thousands of dollars behind a 6-character password.
The good news with that, at least, is that there's 2-factor authentication on any important things. So if you are making a transaction, they will text you about it or something. But my God, 6 characters.
It's horrible. As an aside to the question before about hashing multiple times, if you do that, make sure you undo it in your test suite. Otherwise, you're in for a very long time.
That is true. I think device does that by default as well.
Sweet.
If it's test
That I did not
environment,
know.
then just once.
I had a question more about user experience because at a previous company that I worked at, I think we used the ZX, the one you can't pronounce, and we set it quite high. And I argued a lot with regulators to not follow the NIST standards because they're shit. They've since been revised.
They are changed now.
They've got a bit better. But probably 80% of our support requests was, why the fuck can't I use this password? Which drove our support people mental. Any recommendations on how to deal with that and how to educate users correctly? Because I think that's probably the biggest barrier to entry here.
Were you using the password strength thing as on the back end or the front end or both?
Both.
Right. So like the password, which is also part of the NIST guidelines as well, is have a strength checker that you can see as you type into it. It's difficult, but I don't think like the old guidelines are like good experiences either, right? When you're like, you must have this number of characters and such and such.
No, they're not,
Just,
but people
like-
are used to them.
Yeah,
So they
that's
have,
true.
their password they use everywhere, like you did.
Maybe it's a case at the moment that we're going to have to go through a period of user education, and it might be a little painful. But there's no, I'm no UX expert, so I don't know exactly the answer to this. But I would say that we should be trying to explain those decisions as best as possible. And like I said, like we've set 14 characters on Twilio right now, and people are occasionally not happy about it. You just have to. If you're getting that many support requests, it's a pain. But the more we can put into the hands of the user to let them understand what's going on, the better, I think. And potentially point them in the direction of a password manager. Or there are some interesting. It's new to me as well, but the web authentication API and credentials APIs are really quite interesting for the front end of both generating and storing and securing passwords. Sort of acting as a password manager for users, or indeed using password managers as an actual back end for that. And that's worth looking into as part of a better user experience as well. But I've only heard talks about that as well. But look up the like credentials API for the browser and things like that. Very interesting.
Yeah, Apple's new iOS 12 added one password kind of integration. And that's just like
password
magic.
manager integration. You can have any
Magic.
password manager. Yes, I'm so excited by it. Yeah.
One here.
I have a family member, and I told them they should use 1Password. And they said, yes, they do use 1Password. It said
We're in the bad password
There
joke
we go.
section.
Bravo.
I tried to change my password to incorrect, so when I forgot it, the computer would just tell me, your password's incorrect. Sorry.
With the strong password library that allows you to use a dictionary,
Yes.
does that decrease the entropy for the XKCD password method?
It doesn't, because I can only remember how to do them when I did them in order. Correct. It will reduce the entropy, but the entropy is still high, I think, is the answer there. But let's see about that. Calculate entropy is 37.5. There's a whole blog post on how this is done. But if we then say use dictionary, it reduces a little bit, but obviously there's not just one dictionary word in there. There are arguments that encouraging people to, if you do straight up encourage people to just use 4 words from the dictionary, then that reduces the attack space, much like saying use a special character. So we can encourage this kind of thing, but just telling them to use large passwords is better and safer, and it's not going to give, you want to give as little opportunity for an attacker to imagine what the password looks like. Because as the table of WA government employees shows, users can't imagine what a password looks like. So if we just make them do it long and don't really tell them anything about how to do it, just make it long, the entropy is not affected. And we still get secure passwords. But in this particular algorithm, only a little bit, which is kind of cool. I didn't know that one, actually. I hadn't looked that up. So,
Was there another question?
I tried to change my password to chicken. It said it needs to have a capital in it, so I made it Chicken Kiev.
I suppose my question is, places like Medium have got rid of passwords completely by just saying, hey, you want to log in, we'll send you a link. What are your thoughts on that? And do you ever see that we get away from passwords by maybe doing things like that?
I do think those things are interesting. It also has a user experience connotation to it because you have to get that email, which can be a pain. But it also puts that security in the hands of somebody else as well. So if the email account, which are normally better looked after, or they should be better looked after, are probably a higher profile target as well. So somebody gaining access to email. There was a story a few years back about a guy whose kind of digital life got ruined. It got ruined because they wanted to take over his Twitter account. And they used several different hops to get to the Twitter account. But because that was eventually being able to reset a password via email and get into the Twitter account. So you should look after your email, and that's a pretty good central spot for that. But it does put it in the hands of somebody else. So I'm less confident about that. I want to understand it myself. There's also, we at Twilio push Authy as a 2-factor authentication solution and API. We do suggest every now and again, like, you could just do it with the push notifications and say, yes, log me in, or just dial a code in from your device. But I always think 2 factors is stronger than 1 in that particular case. And having that control is probably better. But it's something to experiment with. And obviously users log into Medium or complain about seeing the banner that tells them to log in because they've read 3 articles. But I don't have a full answer for that, but I like the control.
I have a question. What's your thoughts on devices like the YubiKey?
They're good. Actually, that's what the web authentication framework hooks into as well. So you can actually just do all this credentials, authentication, YubiKey. It's cool. Hardware tokens are one of the more secure things. They're almost also, of course, one of the bigger pains if you lose them, which I can just see myself doing. I complained at Westpac about their passwords. They offered me a hardware token. And I was like, just keep texting me, it's fine. I don't have that much money. Because all right, because texting is also broken, by the way. You don't have to be too technologically advanced to intercept somebody's SMS message and then log in. And people in Germany had their bank accounts broken into because Telefonica gave their SMSs to somebody else. And so it's all terrifying. Different levels, different applications need different levels of that kind of thing. Full-on hardware token, which you need to physically be with, is probably the extreme of that at the moment that we have. But as they become more widely used for the extremely important things, then actually hooking into them ourselves in less important applications, giving people that option, is becoming more available. And again, web authentication API is going to be pretty sweet for that.
One more? I think we'll leave it there.
How long do you think we'll be safe at 14 characters? And do you think we will find other solutions to security before 14 becomes insecure?
You're right. We should just up it to 128. Pretty good there. I mean, once you get to a password manager, it doesn't matter, right? Yeah, I don't know. That's why I think that's why I think if it's important enough, then a second factor is important to include at that point. If you can't rely on just somebody remembering or storing a string to play back at you, then store something else for them. Put something else in their hands. Not literally their hands, because fingerprints are like 10 passwords you just can't change without a lot of surgery. The Indian government. Right. Oh, yeah. It's fun, isn't it? Imagine them just sending out the notification about that. Like, yeah, if you could all change your irises and fingerprints, we'll be back up and running soon.
Just wait a generation, they'll all die. All right, I think we'll leave it there.